Welcome to Spaceverse, your portal to cosmic adventures. This massive star-forming cloud is working surprisingly fast. Near the very heart of our Milky Way, astronomers have uncovered a scene of breathtaking chaos, a storm of star formation raging on an almost unimaginable scale. Thanks to the James Webb Space Telescope, this cosmic drama has been revealed in two different wavelengths, peeling back layers of dust and gas that have long concealed the activity within. The images are not only visually stunning, capturing the brilliance and complexity of the galactic core, but they also shine a spotlight on one of the Milky Way's greatest puzzle. Why some regions, like this one, are bursting with newborn stars while much of the surrounding galactic center remains strangely quiet. What Webb has shown us is more than just beauty, it is a window into the very processes that shape galaxies and give rise to the stars themselves. Why does star formation appear so sluggish at the very heart of our galaxy, while this particular region, Sagittarius B2, seems to be going into overdrive? Let's dive into this cosmic puzzle. Sagittarius B2, often shortened to just B2, is a dense cloud of molecular gas located about 390 light-years from Sagittarius A, the supermassive black hole that sits at the center of our galaxy. To put that into perspective, Sagittarius A is about 4 million times the mass of our Sun. It dominates the core of the Milky Way, and yet, right next door, B2 is stealing the show with its vigorous star-making. At about 150 light-years across, B2 is absolutely colossal. It contains enough raw material, enough gas, to assemble 3 million stars the size of our Sun. That's not just impressive, that's staggering. It makes B2 the largest, most massive, and most active star-forming region in the entire Milky Way. But here's the paradox. B2 is at odds with the rest of the galactic center. As huge as it is, it contains only about 10% of the molecular gas found there. Molecular gas is the stuff stars are made of, the building blocks of stellar nurseries. And yet, despite holding just a fraction of the material, B2 is responsible for half of all the stars born in the galactic center. That's like someone baking half of the world's bread with only a tenth of the flour. This raises the big question. Why is Sagittarius B2 so productive, while the rest of the galactic center lags behind? That's why the James Webb Space Telescope's new observations are so important. Astronomers want to know exactly what drives star formation in B2, and just as importantly, what's stopping it from happening elsewhere around Sagittarius A. Adam Ginsberg, a co-author of the study from the University of Florida, put it best. Webb's powerful infrared instruments provide detail we've never been able to see before, which will help us to understand some of the still elusive mysteries of massive star formation and why Sagittarius B2 is so much more active than the rest of the galactic center. So what could be the answer? One idea is that powerful, tangled magnetic fields are involved. The galactic center is crisscrossed with magnetic structures wrapped around its molecular clouds. These fields may act like cosmic brakes, choking star formation in some places while allowing it to run wild in others. But the details are fuzzy. Astronomers are still trying to piece together how these invisible forces shape the birth of stars. This is where JWST's unique ability comes in. Unlike visible light telescopes, which struggle to peer through the dense curtains of dust that cloak regions like B2, Webb can use its infrared vision to cut through the murk that lets astronomers see directly into the stellar nursery. In this case, researchers presented two complementary images. The first was taken with the near-infrared camera, NIRCam. In this view, we see countless stars sprinkled across the region, glowing through patches of hazy nebulosity. The sight is mesmerizing, almost like a cosmic jewel box. But even Webb's infrared eyes have limits. In some of the darkest patches, the dust is just too thick. NIRCam can't penetrate. That's where MIRI, the mid-infrared instrument, steps in. MIRI is Webb's longer wavelength camera, designed to peer through even denser layers of dust. In the MIRI image, many of the stars we saw earlier vanish. Most of them don't shine strongly at these longer wavelengths. But what we do see is something even more dramatic. The nebulosity itself comes alive. Glowing clouds stretch across the field of view, lit from within by very young, massive stars. These stars are still forming, still growing, and yet they are already powerful enough to illuminate their birth clouds like lanterns. What was once dark and hidden in NIRCam's image now blazes with detail in MIRI's. Together, these images reveal the true scope of the star-making frenzy inside Sagittarius B2. This isn't a quiet factory, It's a chaotic storm, churning out new suns at a furious pace. But there's still more to learn. One of the key goals of these JWST observations is to answer a critical question. Has B2 been forming stars for a long time, across multiple generations, or did something trigger a more recent burst of activity? If the process has been ongoing for millions of years, it would suggest a steady engine of star formation at work. If it only recently ignited, then something dramatic must have happened in the galactic center to set it off. The answer could change how we see not just B2, but the larger ecosystem of the Milky Way's core. And this has broader implications too. Astronomers believe the intensity of star formation in B2 might resemble the conditions of the early universe, when the very first stars were lighting up the cosmos. Back then, star formation wasn't a slow burn, it was an all-out frenzy, with galaxies producing stars at breakneck speed. So by studying B2 today, we may actually be peering back into time, learning how the first stellar nurseries operated in the aftermath of the Big Bang. Think about that. A dense cloud just a few hundred light-years from our galactic black hole could hold the keys to unlocking the history of the cosmos itself. Sagittarius B2 is more than just a star factory. It's a laboratory, a place where the mysteries of cosmic birth, magnetic fields, and galactic evolution collide. And thanks to the James Webb Space Telescope, we are finally seeing it in ways we never could before. From the glittering stars revealed by NIRCam to the glowing nebulae brought to life by MIRI, each image is another step toward solving the paradox of why this one cloud is so productive while the rest of the galactic center remains curiously quiet. In many ways, it's like trying to understand why one city on Earth might suddenly boom with growth while its neighbors remain stagnant. Is it luck? Is it resources? Is it the environment? For astronomers, B2 poses the same questions on a cosmic scale. As more data from JWST pours in, astronomers hope to unravel this enigma. The answers won't just tell us about one star-forming cloud near the heart of the Milky Way. They might help us unlock the story of the entire universe's first stars. And that's the beauty of it. Sometimes the key to the universe's biggest questions lies not in the farthest reaches of space, but in the hidden corners of our own galaxy. As we continue to peer into the heart of our galaxy, clouds like Sagittarius B2 remind us that the universe is both familiar and mysterious, holding answers about our own Milky Way, while also echoing the conditions of the first stars after the Big Bang. The James Webb Space Telescope is showing us that every image, every discovery, brings us closer to understanding not just how stars are born, but how the cosmos itself came to life. If you enjoyed this deep dive into the mysteries of Sagittarius B2, don't forget to like the video, share it with fellow space enthusiasts, and subscribe to Spaceverse for more journeys into the wonders of our universe. Until next time, keep your eyes on the stars, because the story of the cosmos is still being written.